let's get to it. We are finding the distance between points on a coordinate plane. So let's focus in on the green points. Can you find them? The green ones. All right. If you are colorblind and you can't see those points very well, those are the green points. Okay, how far are those 2 points away? And when we measure things on a coordinate plane, we just use the grid as our units. Okay, so like our little key down here is right from line to line. That is 1 unit. Okay, and same thing vertically. Okay, that is 1 unit. All right, so how many units apart are my green? How many units apart are my green dots? Well, pretty simple, right? There's 1 unit, there's 2 units, there's 3 units, there's 4 units, and there is 5 units, okay? So that's 5 units long. All right, let's try the red one. All right, the red points. That's these ones in case you are colorblind. Okay, take those 2 points and figure out how far are they apart. All right, well, if each box is 1 unit, then we have 1 unit, 2 units, 3 units apart, right? 3 units is the distance between those 2 points. All right, now we go to the blue. What's different about these? I hope you're thinking, wait, you can't just count the blocks between them. Right? These are not vertical or horizontal, they're diagonal. So what do? Any ideas? Any ideas that might relate to something we've been doing for the last 3 days? Well, let me see if I can help you out. All right. How about, does this help? If I connect them like that. Okay. Some of you might try to estimate, right? You might try to estimate and say, well, it kind of goes through there. It kind of goes through there. So that's about 3. I guess it's like 3 units, right? But when you have a diagonal line, it's going to be longer than the vertical or horizontal line. So can we apply the Pythagorean theorem? That's the question. How are we going to do that? Well, can you make a right triangle with that blue line as your hypotenuse? So what we can do is kind of like draw a little slope triangle here. Okay, going vertically and horizontally. And then look at that. I have my right angle right there. And now we can count this length here. That's 1, 2, 3, right? That's a length of 3 units. And this bottom one is a length of 2 units. So now we can find the length here, right? That we could represent as C because it's the hypotenuse, the one across from that right angle. All right, and let's plug in 3 squared plus 2 squared equals C squared. You know how to do this part. You're pretty much experts at it. Okay, that gets us 13 equals C squared. And we're going to want to square root that to isolate the variable. Square root there. And my handy dandy calculator says that the square root of 13 is approximately, let's change that to approximately, 3.6 units. Okay? And it makes sense. It makes sense that it's a little bit longer than 3. The hypotenuse is always the longest side, so we knew it had to be more than 3. All right, but it's not a ton more than 3. All right, so now that you see that, let's give it some practice. Okay, let's give it a shot. All right, I have a couple more examples here. All right. Let's take care of the easier ones first. Let's take care of these green ones over on the top left here. That's a green and that's a green in case you can't see as well with the colors. Okay, how far are those 2 points apart? Well, since they're horizontal, we can just count up the spaces. There's 1 space, there's 2 space, that's 2 units. All right, let's go to the black dots. That's this guy. And this guy. All right, how far is this distance? Well, since it's vertical, we can just count the spaces. 1, 2, 3, 4, 5, 6. 6 units long. Now we get to our more difficult ones. Let's go to that blue line. How long is that one there? All right, well, we're going to need to draw ourselves a right triangle. A right triangle. Now, we could draw it here like this and have our right triangle there. Just follow the grid lines. Or we could also draw it above like that, but it's going to give us the same length. So that's a 4 by 3, and that's a 4 by 3. And so it doesn't matter which way we do it. Now we're going to do a squared plus b squared equals c squared. And we have 2 legs here. We're looking for the hypotenuse. So a squared plus 4 squared equals c squared. 9 plus 16 equals c squared. And that gives us 25 equals c squared. What's that last step? That's right. Got a square root. And we get 5. So now we know that that distance there is going to be 5 units. All right, try this last one. Can you get the red dots? How many units long is that line there? All right, you can probably estimate. It's going to be a little bit more than 4 units. Well, let's draw in our right triangle. Okay, we have our right triangle there. Obviously, we could also do one up there if you like that better. But the key is that you make that right angle by going directly down and over or directly up and over. Okay, let's see how long this is. That's 1, 2, 3, 4 units. And this bottom is just 1 unit. So a squared plus b squared equals c squared. We've got 2 legs, so that's 4 squared plus 1 squared equals c squared. That's 16 plus 1 equals c squared. That's 17 equals c squared. And square root. Square root 17 equals approximately, we were right, 4.1, about 4.1 units. So this distance here is about 4.1 units. All right. Now, our goal later is for me to be able to say, what's the distance between these 2 points? 2, 3, and 3, 4. Okay? I just give you this, and I don't have it on a graph. Could you find the distance then? How'd you do it? All right, we'll come up with that on Monday. Hopefully, what we did right now makes sense, and you are prepared to do what you need to do for our assignment today. All right, beautiful day for math. Woodworth out.